Okay, chapter 6 is all about distribution curves, and there's an awful lot in here. Again, but it's much more visual. It's not as many definitions as it is a lot of graphs. We're taking the data and we're doing something with it and doing some evaluation tools on it. Okay, when you're describing distributions, there are three different kinds. Symmetric is when it's the same shape. If you were to cut this down the middle, it would be basically the same shape on both sides. Left skewed and right skewed. Now, I always get these backwards. Don't know why. But when I think of skewed, I think of skiing. So I would ski down this part of the hill. So if it's skewed left, you would ski to the left. If it's skewed right, you would ski to the right. Now, you're not limited to having one hump. And again, keeping up with the skiing, I think of moguls when I see modal. Okay, moguls are the humps when you ski. Okay, so unimodal would mean there's one hump. It doesn't have to be in the middle. Each of these is unimodal. It only has one hump. Bimodal is just like bicycle or bifocals. You are going to have two humps. There are two. And multimodal means you have more than one. Notice they don't have to be the same size. They could be very close to each other and then skewed. But you're just looking at how many humps. Okay. All right. Now, one of the things that can cause things to be skewed is if you have a natural minimum or a maximum, a value that prevents the data from spreading to one side. Okay, so age. You can't be younger than, or if you're talking about drinking, or legal drinking, your lowest value is going to be 21. I'm sorry, I forgot where I was for a minute. Okay. Or if you're talking about distance, you can't go below 0 for distance. A typical value is an interval considered to be a reasonable estimate of typical. So you're looking here and you would have an interval here of what is the typical value. The mean is the average, the sum of all the values divided by the number of values. You know how to find the average of something. How I remember that between mean and median. Median is if you have an odd number of data values, it's in the middle. If you have an even number, it's the mean of the two middle. Okay. Well, how do I remember the difference? A student told me that the mean teacher gives you your average, so mean is average. The median is what's in the middle of the highway. A mode is the data value that occurs most frequently. There can be more than one mode, and there can be no mode. If every data point is distinct, then there is no mode. But if you're dealing with something where the answers are 1, 2, 3, 4, and 5, you could have 7 people that say 3 and 7 people that say 5, and those would both be your mode. Variation is the spread of the value. Variation and range all go together. Okay, these two are definitely connected. Your range is the maximum minus the minimum, which is also the spread or the variation. These are all the same thing. And then an outlier is either an extremely large or small value that can either be an error or just weird data. If you are, I guess I'll do what I did in class. I'll use myself as an example. If you're looking at females and their height, I'm an outlier. The average height of females in this country is 5 foot 4 inches, I think. Well, I'm 6'3", so I'm an outlier, and it's not an error. It's just weird data. Okay, so but it could be, if somebody recorded the data instead of 6'3" as 7'3", that would be an error. That would be a serious outlier, but that would also be an error. Okay. Then we looked at measures of variation. How spread out is the variation is the spread of the data. How do we deal with that? Okay, so if we have a skewed distribution, you're going to look at the 5-number summary. And the 5-number summary is the low, the lower, the low value, the lower quartile, the median, the upper quartile, and the highest value. Okay, so the low value is your smallest data point. Your high value is your largest. So I start with these two. The median is the middle or the average of the two middles if there's an even number. So from here you have 50% of the data here and 50% here. Then I look at the low value and the median, and I find the median of those two. So since this whole thing is 50% of the value, then 25% is here and 25% is here. Then I do the same thing up here. I find the median of the median and the high value, which means that 25% is up here and 25% is down here. So the spread on the box plot tells you the low value, the median, the lower quartile, the median, the upper quartile, and the largest, and then each of these, each box has 25% of the data, and each whisker, it's called a box and whisker plot, has 25% of the data. And then how large it is tells you how spread out it is. This data, 25%, is spread out over a larger value than this 25%. Okay, symmetric distribution, the center is the mean. If it's skewed, the center is the median. And the deviation is the difference between a data value and that mean. Okay, and we're going to talk about normal distribution and standard deviation in just a minute. Okay, so here's how it looks when you have a left skewed, symmetric, and right skewed. The median, of course, is right in the middle. Okay, it is halfway in between the low and the high. Halfway in between the low and the high. If it's symmetric, we also know that the tallest value is the mode. Okay, because that's the frequency. If it's symmetric, the median, the mean, and the mode are all identical. If it's skewed left, the mode is going to be to the right of the median because the median is not the biggest value, but the mean is going to be on the other side. If it's skewed right, the median is going to be halfway in between, but the mode is the tallest value, which is going to be to the left of that, and the mean is going to be to the right. Now, why is the mean over here? Because you're going to have more values with more data points with lower values. So when you average them, that means that the mean is going to be skewed this way. Now, the normal distribution is when you have a symmetric graph. Nothing is ever perfectly symmetrical, but this is how a normal distribution works. This little symbol here means the mean, so it is right smack dab in the middle. This symbol here is for a standard deviation. Now, we didn't talk about standard deviation and how to calculate it. I have a calculator that does it for me, so I don't have to use the formula. There is one, and you're welcome to look it up or take if you're really interested in statistics, it's a really interesting course to take. Okay, but what this means is if you have a normal distribution, the curve looks the same for everything. The only thing that changes here are the numbers on these axes. You have 1, 2, 3, 4, 5, 6, 7 values here. You have your mean. Okay. To the right of that, you're going to add 1 standard deviation. Then 2 standard deviations, 3 standard deviations. To the left, from the mean, you're going to subtract a standard deviation, subtract 2 standard deviations, subtract 3 standard deviations. And this tells you, these values right here, tell you that almost all of your data falls between the -3 standard deviations and the positive. In between a positive and a -1 standard deviation, 68% of the data falls in this category. So there is 68% of the data in this category. Within 2 standard deviations, left and right, 95% of your data will be between those 2 values. And finally, 97.5% of your data will fall between positive and -3 standard deviations. So let's just do an example. Let's say we have a median of 12 and a standard deviation of 1.1. Okay, we know our mean goes here. One standard deviation to the right means that I add 1.1, and that gives me 13.1. Add another standard deviation, and that gives me 14.2. Add another standard deviation, and that gives me 15.3. If I subtract 1.1, I get 10.9. If I subtract 1.1, I get 9.8. And if I subtract another 1.1, I get 8.7. So whatever this study was, I know the mean is 12, the average value is 12, and I know that 68% of the value falls between 10.9 and 13.1. 95% of the data falls between 9.8 and 14.2. 97.5% of the data falls between 8.7 and 15.3. And that means beyond that, outside of that, there's 2.5% of the data, which means 1.25 on this side and 1.25 on this side. Now, we didn't talk about z-scores. Even when we do talk about z-scores, I did not test on it last spring, but it tells you it is the number of standard deviations a data is from the mean. You're going to have a data point in between 12 and 13.1. Because you know 68% of the data, these are not the only data values. These are just the cutoffs for the standard deviation. So if you want to find out where the z-score is, where a data point is, then you can take the data value minus the mean and divide by the standard deviation. So just to show that, say for example, you have a data value of, let's call it 13.6. If I do 13.6 minus 12 and divide it by the standard deviation, which in this point is 1.1, that will tell me where this falls. So if I do 13.6 minus 12 divided by 1.1, I get a z-score of 1.45, which means it is, since it's positive, it's to the right, 13.6 is 1.45 standard deviations from 12. And that makes sense, okay, because 13.6 is in between 13.1 and 14.2, which means it's going to be between 1 and 2 standard deviations. Okay. All right, well, that's kind of the end of it. Again, my recommendation, in addition to doing the homework, the review is very comprehensive and has practice problems. Go back and make sure you understand what they want in a question and how to answer it. And let's see if there's anything else. Remember, this is both filled in except for the part that I drew, if you don't want to copy down the definitions, but I would highly recommend that you take a blank one of these and fill out as much as you can on your own in order to help prepare for the test. Okay, that's it.